era of technologies. So at that time, Microsoft was still on the peak, which means they were still the leader in, I mean, even now they are the leaders in operating system and software services. But still, what were they doing? How were they doing it before .NET came into picture? The first thing is desktop applications, which is something which is very famous for Windows, because if you remember, first operating system which came from Windows or Microsoft is DOS, disk operating system. And then they moved on to 95 and a lot of other versions are there. Now we are in Windows 10. We are looking for a new update soon. But still, these are all GUI. I hope you know by the full form, graphical user interface. So these things were there before .NET came into picture. So how did they do that before .NET came into picture? There is something called Win32 API, Application Programming Interfaces. They are available in the Microsoft operating system by default. Right from 95 onwards, you can see those small applications. Those who have used will understand that. It is much better than DOS. That was the idea. DOS and Windows 95. Obviously, we'll choose Windows 95. So that was till I think Windows XP, Win32 API was the one which was used. Apart from that, they had something called MFC, Microsoft Foundation Classes, which is written in C++. That was there. And obviously, the most famous and very much attractive way of developing desktop application is VB, Visual Basic. All right. Please note, Visual Basic is right now owned by Microsoft, but Basic, the first language which we had, beginners, all-purpose, symbolic instruction code, that language was taken into Microsoft and they put a visual aspect to it and then they called it Visual Basic. Please note, it is still the language, what you are writing there is Basic. In that one, you have a visual interface. That's why it's called Visual Basic. But after .NET came in, it was changed into VB.NET. It is Visual Basic on top of the .NET framework. We'll see how it happens shortly. This is for Windows. What about the other applications what we had? We didn't have much mobile applications, but web was still there. There were websites that time also. So for websites, they had a separate technology called ASP. .ASP will be the extension. Please note, not ASPX, it is ASP. Most of you would have come through W3 schools. If you check W3 schools website, it is mostly done with ASP, not ASPX. All right, ASPX is what we are going to study this semester. But before .NET, it was .ASP, active server pages. This name somewhat similar to what we have learned in the last semester, Java server pages, JSP. All right, so this is Microsoft's first server-side script engine for dynamically generating web pages. So this is before .NET. Let's move on. What is .NET? Okay. There are a lot of definitions, guys. I'll show you the website, the official website of .NET also shortly, in which how they have described themselves. Now, please note, I had to revamp all my slides because what I had taught, let's say 2-3 years before in .NET is not there now. I had to revamp the entire slide to match with whatever we are learning. Now, before I proceed with what is .NET, one more thing you need to know is that our syllabus is right now teaching, or right now comprises of .NET framework. Okay, please note that the current version, what they are looking for us to start is .NET Core. All right, so why I'm telling this is .NET framework only works or primarily works on Windows-based systems. Now, since the world is changing so much, they also would like to come into the game of multi-platform or platform-independent technology. So they have changed it into .NET Core, which would work in multiple platforms. So, but .NET Framework, what we are learning will only work in Windows. Please understand the difference. I cannot teach you .NET Core right now because it is not in the syllabus. The syllabus only focuses on .NET Framework. So, what is .NET? Okay, according to Microsoft, right now, please know this is not the definition what I used to tell. It was just told .NET is a software platform for primarily running Windows applications. But now we are calling it as .NET is an open source, general purpose. Please, I will underline that word once again for you. General purpose development platform. All right, please remember this. It's a general purpose development platform. Now, since we are studying web applications this semester, it does not mean that .NET can only develop websites. Please remove that notion from your head. .NET is a platform. Okay, remember that. It is a collection of languages. I want you to note that word, collection of languages and libraries that all work together to build, again, I'm focusing on that word, all kinds of apps. All right, I'll tell you what those are. It, by the way, it is free. It's right now cross-platform. Right now it is open source. But what we are developing is kind of free. It is not open source and it is not cross-platform. Whatever we are doing right now, but .NET in the current scenario is free, is cross-platform, is open source. Okay, and it is used to develop what type of applications? Terminal. When I say terminal, command prompt applications like black and white screen, like how you have done Java, C, Java, all those things, C++, terminal-based applications, desktop-based applications, web applications, mobile applications, cloud, IoT, big data, whatever you take, whatever technology you could think about, everything can be done with Microsoft .NET framework. Please remember this, everything, whatever you can think of from a computer science perspective, what and all you can do from a computer science perspective is available inside .NET. Please do remember that. Now, it has a lot of key features. The first thing I want you to focus on is support for multiple programming languages. Now, when you start thinking about .NET, there is a normally every semester when we begin, I tell this before we start, okay, how this picture came into the scene right now. Microsoft .NET. Why Microsoft had to bring up a totally different framework for their applications? You should understand the history here. Java was very famous, and a lot of people started moving from whatever they had studied, like C, C++ in the early days, to Java. Now, the Java developing part came a little bit famous, and it is still famous. It has become like a standard in the programming world. But at that time, please remember, like how you are, like how I have taught .NET framework for people, like say 5 years before we had taught .NET framework, but that is useless now. And it goes on like this, right? So what happens to people who have already learned this previously? Like when Java came into picture, what happened to the previous languages? C, C++, Basic, like Pascal, whatever languages they had before. What about the people who have spent money and time and experience in learning those languages? Now, none of the clients would like to use those languages. So what they want is, they would like to take something new, like Java is new, so we want our project in Java. So what happens is, to the people who have not learned any new technology, they'll have to either adapt to the new one or perish. They'll have to just stop working for software and then go for some other job. So what Microsoft did was, it collected all other people who had learned all other languages and put them up a general platform. Now, the thing is, either you have learned VB, maybe you would have learned Basic because you are, imagine that time, okay, not now, nobody starts learning Basic, we learn VB or VB.NET. But imagine if we had learned that in that olden times, you have learned old language like Basic, and you don't want to, because you're already grown up and you are almost about to retire, and then they're telling you you have to learn new language, you would not be preferring that. So what they did was, they said those languages which follow a particular standard can come under the platform of .NET. So normally how a programming language would work, you write code in that programming language, you compile it, you'll get a bytecode or something like, or intermediate code, and then you'll execute it on your system and you get the output. Simple. But what .NET has brought into the picture is, let's forget the language. You use whatever language you want. Okay, as long as they all follow a standard, I leave the choice of the language to the developer. Let the developer choose the language which is comfortable for him. Okay, I hope you're following. Let the developer choose the language which is comfortable for him and then develop it. Once he develops it, what .NET would do is take that language, compile it into its own language, an assembly level language. I hope in order to understand this, you need to understand low level, middle level, high level languages. All right, low level language is human readable, but still it's not that friendly with us. Like for example, assembly, you would have written MASM codes for microprocessor. Those kind of codes would be very complicated for us to understand if you write more. If it is just adding two numbers, it's fine. But if it is a big program, you would find it difficult to understand that. So in order to avoid that situation, what we would do here is, you write code in whatever language you want. I'll compile it into my own language. .NET's the framework would do that, and then execute it. Which means I don't care which language you speak. Whatever language you speak, I'll take that and compile it into my language, and I'll pass it to the system. This is the idea. That is why it supports a lot of programming languages. All right. So most famous ones are C# and VB. Okay, since VB is kind of learned in BCA, and most of them are already familiar with VB. We don't want to give VB because you already learned Java in this college. So C# would be the optimal choice for people who have already learned Java. All right. It has asynchronous concurrent programming models. It has a lot of benefits. I'll not bother about this later. Okay. But just remember the word native interoperability. Now, what if I have recruited people, like 2 people who know C++, 2 people who know BASIC, and I want all those 4 people to together work in one project? Is it possible? Normally, no, it's not possible. But under the .NET framework, since all your languages are getting compiled into the same language, you can operate with people who are working in different languages. So you understand what I'm trying to say here is you are giving the focus on getting the product, not the language. Now, whatever program we have developed so far, we are focusing much on the language part alone. We are not bothered. I mean, we are not bothered about whether other languages will be able to adapt to it and all those things. We are just focused on getting our work done in that particular language. But when it comes to .NET, it does not care of the language what you are using. You choose one language. If with that one language, you can develop whatever you want. You learn one. That's all is the idea. So if you have already learned something, just adapt to this one. That's all. And which enables a wide range of scenarios across multiple platforms. Please understand this: multiple programming languages, multiple technologies, and multiple apps can be developed with .NET. So .NET is not just let's say a programming language. It is a platform on which there are a lot of things which you can use. The framework. Okay, I'm not going into the technical part, but I just highlight some words. It is a set of services, classes, data types. That's all I will tell. Remaining, I think you can read it. I just focus on the 3 words: services, classes, data types. These all 3 together, which will enhance your productivity. When I say yours, developers' productivity, and it gives you easy access to the functionality which is given by Windows, the underlying operating system. Now, I'm using the word Windows here because I'm teaching .NET framework. But if I'm teaching .NET Core, I would not say Windows. I'll say the functionality provided by your operating system, whatever operating system that might be. Okay. Now, it handles, this is something which I focus on again. It handles a lot of low-level details, plumbing details, which means it's not something which you need to bother about, that are required for components to work together and to scale and all those things. All right. It also handles memory management. It handles a high level of thread safety. Okay. So a lot of things are benefits of .NET framework. And this is the important thing. It allows you to concentrate on building functionality instead of worrying about management level details. This is very important about .NET framework. Now, let me keep it simplified. This is not the architecture. Please note, I just put a simplified version because before getting into the technical words and all those things, I just want to tell you .NET simplified. At the bottom level in any technology you are learning. Okay, just take any technology you have learned, C, C++, maybe desktop application, web application, mobile application, whatever it is, at the bottom level, you will have these. You have a hardware, that's important. Okay, but we are not talking to hardware directly. We obviously talk to the hardware using the operating system. So at the underlying level of any technology, these 2 would be there: operating system and hardware. All right, that I think everybody is clear about. Now, what we are going to learn is going to be on top of your operating system. Please do remember this. All your Windows machines right now, okay, I'm talking about Windows which came after Windows XP Service Pack 3 onwards, has .NET framework inbuilt in your system, because your system is, Windows OS itself is developed upon .NET framework. So when it comes to our mechanism, we'll be installing different frameworks. Like there are a lot of versions in .NET, like 2.0, 3.4, like that. There are a lot of framework versions. So one version which we are working, when you install Visual Studio, automatically this will automatically get installed. So no need to worry about it. It will be there. And on top of that is what we are going to write. So what we are writing is only the top part. Remaining part we need not bother about. So you just need to create a .NET application, which will in turn be taken care by .NET framework to execute on your operating system, which will in turn talk to your processor and get it done. This is simplified version of .NET. This cannot be written for the theory code, but this is just for your understanding how it works. This is the architecture. Okay, let's not get carried away. At the bottom, just start at the bottom and the blue bar on the right side. Okay, so you see Windows at the bottom. Ignore the word COM services. Okay, I'll not focus on that. Let's only focus on the word Windows. All right. The reason why it is mentioned as Windows is, again, it is .NET Framework. If it was .NET Core, that Windows will be replaced with any operating system. That's all. All right. And the right-hand side, you see Visual Studio. Okay, please note, you can develop .NET applications without Visual Studio also. But just imagine writing so much of code and compiling, like imagine Android Studio. Without Android Studio also, you can develop Android applications. But what happens is you have lots of low-level work. Like you have to write the Java code, you have to put it in a package structure, you'll have to package it into an APK, then push it into the phone. All these things are there. Nothing you did actually. We just developed it and you clicked on play. It made it simple for you, right? So Visual Studio is also going to do the same thing. It is going to take care of overall management of your .NET application development so that it is easy for you to start developing applications. All right. So now let's go to the topmost part. You see there are a list of languages written: VB, C++, C#, JScript, IronPython, you have F#, you have X#, you have a lot of languages there. Dot means there's a lot of languages there. Okay, you choose which language you like to develop with. Okay, I'll repeat again. You choose which language you would like to develop in. Now, can I choose VB? Yes, you can choose VB. I'm not saying you cannot. Okay, please note, the reason why we are teaching C# is a different issue. In .NET Framework, there is no distinction between languages, but Windows will obviously recommend C# to you because it is their own language. I hope you get the flow. VB is an acquired language. C++ was not developed by Microsoft. It was also incorporated into .NET Framework. C#, but it was created from the scratch by .NET people, with Microsoft people. So it is their language. That's why they are focusing on it. And lots of support is given to C# compared to other languages. That is why we also would prefer to take C#. Not only that, it's somewhat similar, or it resembles Java. That's why we took that. Okay. Now, there are some words which are there. Look at the second word which you see there, common language specification. Now, before I get into that word, specification. Imagine that you're buying, let's say, a game or a hardware device, like say a mouse or a keyboard. When you buy every hardware device, what you buy, on the box, there will be something called minimum required specification. Like say you should have Windows 7 and above, you should have at least this much RAM, this much hard disk should be there. These are specifications given. So now imagine if I bought a game which says I need minimum 1 GB of graphics card. Now, if I don't have that, will I be able to run it? No, they don't recommend that you run that because they require minimum 1 GB of graphics card. Or if it requires minimum of 4 GB RAM. These are specifications. What about language specification? Now, .NET Framework has given a set of rules. If you follow that rule, you can be part of .NET Framework. That's all. So it means it doesn't matter which language. Maybe you have created your own language. You just want to see whether .NET will support it. Yes, just go and check common language specification. If the specification matches your language, you can be part of .NET Framework. As simple as that. That's the top level. And middle level, the one which is somewhat in some different color there. Okay, that is what and all you can do with .NET Framework. You can develop. What we are going to do is ASP.NET. Remaining you can right now ignore. We are going to focus on ASP.NET. You'll be developing ASP.NET using C# in this subject. Okay, and after that you have base class library. All these are part of whatever technology you choose. And one more keyword I want you to focus on is the last one, CLR, Common Language Runtime. Okay, that is somewhat like JVM for us. In Java, you have JVM. In .NET, you have CLR. Please note, none of them use a specific language. They just use the word common language. All right. As soon as you hear the word, you should understand these are not specific to one language. It is not specific to VB. It is not specific to C#. It is common. That's why the word goes common language specification, which means a specification which is applied for all languages in .NET Framework. Common language runtime, a runtime which allows all languages compiled code. That's the idea. So this is the architecture. I will not get into much of the architecture part because I've already explained that here. Let's go into the runtime part, the CLR. Okay, a runtime, before we go into CLR, just need to understand what is a runtime. Runtime is something, a part of a language which executes the code. That's all. Okay, so on top of which your software will run. Those who have done Java, you know JVM. You have never used JVM actually because you just wrote Java C and Java and compile. In last semester, you just clicked on the play button and it worked. But please note where it got executed, not on your hard disk. It was executed on Java virtual machine. JVM is a runtime. So runtime is part of a language which executes code. That's what I want you to remember. And it generally makes your OS available to your programs. This is general work of a runtime. It includes starting, stopping your application, threads, processes, everything. Examples. First one, what we have worked with is Android runtime. That's what we have been working with the last semester. And Java virtual machine, the previous semester, I think you have done that. And VB run. Okay, this is for not VB.NET. Please remember, the moment you hear the word .NET, all those applications are executed by only one runtime, which is CLR. VB run is to execute Visual Basic applications, not VB.NET applications. This is Microsoft Visual C++ runtime. This is, I told you before .NET there was C++. This is one more runtime which was available. Objective-C for Mac OS and Objective-C runtime for that particular language. Node.js, I think you're learning it now. It's a runtime for JavaScript, which you will be learning shortly. I think you started already. So that is one. Okay, and how is CLR different? These are other runtimes which are available. How is CLR different from what we have discussed right now? CLR is not for a specific language. If you noticed the previous ones, all those runtimes are specific to one language. Okay, starting with JVM, it's specifically only for Java. No other language can be executed there. VB run, Node.js, all these are specific to one language. But CLR, it provides a unified runtime environment for a multitude of programming languages. When I say multitude, many. That's the idea. Many programming languages, which means CLR is not specific to one language. That's one. Unlike Java, for instance, that's what I just told. Okay, I've highlighted one word there. I wanted to notice that common language specification. .NET runtime executes programs written in any language that meets its common language specification. The life of the existing solution, as well as the productivity of developers whose selection of language is limited, which means there might be people, this you might face later in your life, that imagine that you join as a Java developer. I'm just giving an example. If you join as a Java developer and you are totally accustomed with Java, and once you become like 10-15 years into the field, then later suddenly they say that you will have to choose a new language and then start working with it, which might be difficult for people who are already in that particular age. So if your language selection is limited, you can still work with .NET because .NET will take care of any language which follows its specification. That's why CLR is different. And this is one code. I mean, this is something for theory purposes. It's called managed code. It's very simple. It's a term which is coined by Microsoft specifically to identify computer program code that requires and will only execute under the management of a common language runtime. That's all. A virtual machine resulting in bytecode, which we will see later. But just remember the keyword. The term is coined by Microsoft. It's only available in Microsoft terminologies. Managed code, which means it is managed by CLR. That's all. That's a simpler way of telling it. So that's one. And it also provides automatic garbage collection, just like Java. So I'll not explain much about that. Now, another keyword which I want you to understand here is common intermediate language. All right. So so far, whatever we have done, let's say, for example, if you're writing a C program, you compile it. What will come as the output? Okay. I'm asking about the .obj file which comes, or in Java, if you compile a Java file, you'll get .class file in the middle. But when it comes to Microsoft in common language runtime, you get one some library. Okay, let's not. I'll not discuss that right now. But just remember, it is not converting or compiling it into bytecode in the beginning itself. It is just converting it into another language. That's what I'm saying. All other languages will compile from one language to another immediately into a bytecode, which is assembly level. Here also, it will be compiled into a bytecode, which is assembly level, but it will be based on which language you have chosen. Imagine if you have chosen C#, it will compile it into common intermediate language. Now, please note, the language which I used is C#. But once I compile, what will I get? I will get common intermediate language. What if I chose VB? I compile using VB compiler. Output will be common intermediate language. What if I use C++? You compile using C++ compiler, output will still be common intermediate language, which means it doesn't matter which language I speak, all my languages will be converted or stored in the format of a common intermediate language. All right, so remember that. And these are the services of CLR. I'm not going to tell, these are all for theory purposes. What and all it does, it converts, first was code management. Second one, it converts IL. I hope you will now understand what IL means. Intermediate language, the middle language, okay, to native platform dependent code. Okay, and please note I've used the word platform dependent. All right, in .NET Core, it will be platform independent. Whichever platform you're executing, for that, it will convert just in time. Okay, it gives metadata and it has memory management, code access. All these things are theory part. You can take that, and it has exception handling, including cross-language exceptions. All these things are services of the CLR. All right, so I'll just skip this and let's come into how it works. Okay, this is just since you already know Java, I'm taking this as an example. I take a hello.java, I compile it. Okay, using Java C space file name .java, I get hello.class. That's the bytecode. That's what we call. And we execute it on the JVM, just in time, and then it gets converted from bytecode into zeros and ones. Our ultimate target here is zeros and ones only, because we are trying to talk to a machine. So JVM will do it using the bytecode which you have generated from a Java file. But what about if I use .NET? Okay, please note I said .NET, not a particular language. But in that .NET platform, you have to choose a language. Here, I've given an example as VB. When I start C#, I'll talk about C#. Imagine you write a file called hello.vb. Okay, and that's the source code. You compile it. Okay, you will get hello.exe. I guess by now you know what that means. All right, because almost all things which you run on your Windows is an exe file. All right, so you can understand what is there in that exe. The exe is nothing but common intermediate language. All right, in Java, you call it as bytecode. Here, we call it as CIL. Common intermediate language. All right, once you double click on this exe, what happens? It executes on top of your CLR just in time. It converts all that common intermediate language into native code. Okay, I'll talk about that a little bit more later, the types of JIT just in time. But this is the idea. I hope this is clear for you. How Java is working, same way we are also working here. But then there's a small difference here. That's it. All right, but either way, we will not see this difference because we are not going to do all these things. We are not going to sit and compile code and then run it. We are just going to click on the play button and it's going to run. All right, I'm just telling you how it works internally. That's the theory part of our subject. So this is the execution model. What I just told, I'm repeating it again in another diagram. You choose VB, you choose C#, you choose C++. You have to use their compiler. VB's compiler for VB, C# compiler for C#. Like that, you use it, and you see output, they have written MSIL in this diagram. I purposely put this diagram just to show that earlier we used to call it as MSIL. By now you could have guessed what is MS, Microsoft. Okay, Microsoft Intermediate Language. It was called as Microsoft Intermediate Language, but because of standardization of the language, now it is called Common Intermediate Language. It is not belonging to Microsoft. It is just Common Intermediate Language. And where is it executed on? It is executed on that big block called Common Language Runtime. Now, one more word I would like to bring into picture is managed code. I guess by now you know what is managed code, the code which is managed by CLR. Simple. So CLR is taking care of that. And what is the work of CLR? It converts that intermediate language code into machine code. When I say machine code, there are a lot of words you can use to describe that. Native code or binary, zeros and ones, whatever it is. Whatever your hardware understands, your operating system takes that and then gives it to the hardware to process it. This is the execution model. I hope this is clear. Can you just guys give a yes so that I can proceed?
Yes, sir.
Yes, thank you. All right. Because it's so different when nobody speaks. Anyway, all right. So now let me just carry on. Common language specification. What do you mean by specification? I've already told you about this, that there is a set of requirements for .NET languages. Okay, you set a set of rules, and if the rules are followed by this particular thing, then you can be a .NET compliant language. All right, so C# obviously follows all the rules. All right, to be on the safer side, I'll say that Java also follows the rules, but since they are rivals, it's not officially supported by .NET. But then the rules which .NET requires need to be followed by the languages which are coming into its picture, and it can take it. That's all. Okay, so why is there that set of rules given? The set of rules are given because whoever is coming inside .NET must be able to understand each other. Irrespective of what language you speak, we must be able to communicate with each other. That's the idea of .NET, to integrate a lot of languages so that you don't feel left out because I know only one language, I'll not be able to do anything. No, .NET would still make sure that with that one language, you can develop a multitude of technologies, multiple technologies. Okay, so anyway, that's the idea of common language specification. It ensures that complete interoperability among applications. Now, it is difficult to communicate because see, sign language is also a language. Whatever we speak is also a language. But then there are different grammars available in different languages. So when it comes to this particular thing, we need to make sure that all of us have a same grammar in which we can communicate with each other. Then it becomes a common language specification. That's all. Inside that, there is one more small keyword called common type system. This becomes a big confusion when it comes to different languages. If you have noticed, most of you would have this confusion in MySQL and Oracle. MySQL has a set of data types. Oracle has a different set of data types. All right, so which means I cannot work with, for example, there is a word called tinyInt in MySQL. I can't use that word in Oracle. That's the idea what I'm saying. So the types like that, programming languages also have some data types like int, float, boolean, double, all those things. But what happens if I have a different data type altogether and I cannot talk to another language which does not have that data type? So that is why they have something called common type system. If you are bringing your language into this framework, you will have to follow the same type systems. That's the idea. Okay, so it just describes a set of types which they have in common. That's what I just told now. Let me just continue. CIL, formerly called as MSIL, Microsoft Intermediate Language. All right, so please note this is the full form or definition of it. It is the lowest level human readable programming language. I want you to focus on those words. It is the lowest level a human can read this code. All right, it is like assembly language code. Because assembly level language is a low level code which can be read by us but not understood by the system. Okay, so CIL is something like that. It is the lowest level human readable programming language, but it is defined by something called Common Language Infrastructure Specification, and it is used by the .NET framework. Okay, I know that I put a lot of keywords right now. I'll recap all those 4 keywords once again. Just remember these words. Okay. So languages which target a common language infrastructure compatible runtime environment compiled to CIL, which is assembled into bytecode. This is what the technical definition goes about. We need not bother about these guys at all. Please understand this. Okay, I'm just telling this because this is the theory part. In practicality, we will never bother about what is happening here. All right, these are all the background things. Okay. So CIL is an object-oriented assembly language. That's what I just told now. And it is entirely stack-based. It is executed by a virtual machine. In our case, the virtual machine is called CLR. Okay, now it is officially called as CIL, Common Intermediate Language. Now, most important thing, how does .NET applications work? Okay, the process by which how .NET applications will get executed or how they will work. So let's start with the first step. What will we do when we want to write an application? Okay. Now, again, I want you to imagine that I'm doing an app which has, let's say, let's just take the example of our SQLite program which we have done in Android. Imagine that instead of doing it for Android, you're doing it for a website, or if you're doing it for a desktop, how would you do it? Okay, please note, the first page has a list of, let's take students, list of students, and you will go to another page to add a new student. In the list, you can give edit and delete. If you click on edit, you can go to an edit page and then edit it. So which means this CRUD application has at least 2 to 3 pages. Okay. Let me not use the word pages. Let's say there are 2 to 3 files. Let's say retrieve.java, insert.java, update.java. Like that, we have different files. Now, all these 3 codes or 3 files has source code in it. I hope you're following. Every file which is there has a source code in it. Now, what is the first step of the working? Number 1, compile all. Please note, in Java also, in Android also, just because you wrote 3 different files and executed one activity doesn't mean only one activity will get compiled. If you have 3 activities in your project, in other words, if you have 3 Java files in your project, all the 3 Java files must be compiled. Okay. Please remember that. It's not normally till now you would have worked, I mean, before Android or before you start with enterprise level applications, normally you would write one Java file, you compile it, you get output. One C++ file, you compile it, you get output. One Python file, you run it, you get the output. But when it comes to applications, like actual applications, you can't just work with one page and get it off. You will have to at least write 2-3 pages because you will have to divide your work, otherwise it becomes very complicated. So imagine I have 3 files. Okay, I am going to take, instead of Java, I'm going to use the word CS. I hope you can follow, C#. All right, so I have insert.cs, retrieve.cs, update.cs. This source code, whatever you write, will be converted into CIL. That's the first step. Source code is converted into common intermediate language. Now, how many source codes? I have 3 files, 3 C# files, which means all the 3 will be converted into 3 different CIL files. First step. Second step. If I have 3 files, I'll not be, for example, when you're running Notepad or let's say Word, you run only one exe. That exe has to call the other ones, just like how you open an APK. If you install an APK, the first activity which comes in front is only one. But then others are also there. They'll be linked together. In other words, you have put 3 activities, you have assembled all the 3 activities into one APK and you gave it to the user. I hope you follow. Right? Every application has a lot of activities, lot of Java files. I'll compile them and give it as only one APK, but that one APK will have a lot of Java files inside them. So what will be the obvious second step is to assemble them into one bytecode, and a .NET assembly is created. Please note the word assembly. Assembly is just bringing them together, assembling them into one place. So in .NET, assemblies are 2 types. One is process assembly, .exes. Another one is library, dynamically linked library, .dll. We will be working on .exe. Sometimes it might be .dll also, but exe is an easy form for you because you have worked with it. Now, if you double click on an exe, let's say for example, word.exe, you double click on word.exe. Do you think that entire Microsoft Word is written in one Java file or one C# code? No, obviously there will be lots, but they're all merged together and shown to you as, one exe. So just think the second step is CILs. Like for example, there are 3 CILs now. All the 3 is now assembled into one bytecode and one .NET assembly is created. This is the second step. I hope till this it's clear. The third step is you double click on that exe. I'm telling in layman's term, you just double click on the exe. What happens? Upon execution of a .NET assembly, in other words, when you double click it, bytecode is passed through the JIT compiler. Please note the word just-in-time compiler of the CLR to generate native code, which means when you double click on the exe, the CIL code which is written and kept in that exe is converted into native code that moment only. I hope you follow. The exe file which you have on your desktop or the system does not have native code. It has CIL. When you double click on it, that CIL is then converted or parsed through the JIT compiler to generate native code. Then you get zeros and ones. And then it is very simple. The native code is understood by your processor. Whatever processor you're using, the native code will be for that particular processor. This is the working process. Okay, I'll show this in work shortly, probably next class. In this class, we'll try to wind up soon. Okay, so this is the working process. Guys, there are 80 students, 80 people now registered. So I'll just take attendance so that we can, yes, I've marked it. Hopefully. Yes, okay. I think this is the highest we have got today. So I think we'll stop. Yeah. This is a pictorial representation of the same thing what I just told you. Okay, but then I've not included that 3 different files and all. You write code in C#, you write code in VB, or you write code in J# or F# or whatever language .NET offers to you. Take that language, write the code, compile it. And then you see that the dotted lines, there's a blue color thing which is running around. That is called common language infrastructure. converting into CIL, executing on the CLR. All these things are called as common language infrastructure. Okay, you can read the definition also. I'll be passing the slides to you guys. Don't worry about it. Okay, so that is one. Now, common intermediate language, common language runtime. You see the last line in that entire diagram is 0, 1, zeros and ones, in other words. Okay, so that's what the system understands. And above that, whatever is there is for our understanding. So this is the working process. Now, today, what and all we have discussed in this slide. I think the remaining part I'll take in the next class. With this, we'll stop. Just remember all these 4 keywords. 1. Common language specification. What is it? It is a set of rules which any language has to follow to be part of .NET framework. Second one, infrastructure. Whatever language follows that specification and converts into intermediate language and then gets executed on CLR, all these things can be considered as part of common language infrastructure. Infrastructure means it's just the name which holds everything together. So these things are together called as infrastructure. CIL is the intermediate language which gets generated when a specific language is getting compiled. Any language you take, it will get compiled into common intermediate language. Earlier, it was used to call as Microsoft Intermediate Language. Now, after that, you have common language runtime. That's the last one, which is the most important one, which is like the execution environment of your .NET applications, or in other words, you can call it as runtime of your .NET applications. I think with this, we'll stop, guys. Remaining, we'll continue in the next class.